Thank you for joining us today. I am Rob Terlizzi, the head of product marketing here at Lightbits Labs, and I am here with one of our technical experts, Rob Blomendahl. Rob, if you don't mind introducing yourself to the world.
No, not of course, Robert. Thanks for introducing. So my name is Rob Bloemendaal. I'm Principal Solution Consultant in EMEA for Lightbits and having 25 plus years storage experience as a pre-sales engineer and architect.
I asked you here today because I know that you just finished a large presentation with a financial customer of ours and put together a new, more concise demo. I was hoping that we could take that and present it to the world. I'm going to ask you in a minute to bring up your screen and walk us through everything you did, with our customer.
I would love to. So, here the cool thing for this customer, right, was seeing things under action, not just a demo how to show how it works, but how it truly comes together when you're running performance as well. So that's what we built for the customer, and I'm happy to show you.
Thank you.
What you see here, right, is basically Photon. Photon is our UI interface for Lightbits and ability to manage multiple clusters, multiple servers, and of course, multiple volumes. Imagine that you walk in the office in the morning and you have dozens of clusters, hundreds of servers, and thousands of volumes looking at Lightbits, right? You want to walk in and you want to see three things, right? I want 3 times a green bar. And that's exactly what we're showing you here. A green bar for the cluster, for the server, and for the volumes. I'm safe, right? First thing I would like to know for walking as a system admin for my storage. What we're showing you here as well, I'll just stop it. This customer wanted to see everything under load. So yeah, I'm seeing all these demos about integration with OpenShift and that sometimes I can see live integration, but not all the time. But it's always without not a lot of load. So my plan is to run block size 512 bytes because that's what my applications are using. I'm not running on 4K, I'm running 512 bytes, building a system with more than 1 million IOs and show me, right? So what are you looking at here, right, is we have virtualized through OpenShift. In the background, we've got 14 virtual machines running, which I'll show you later. But look at this, right? So basically what we've done, and this is our Grafana, this is our dashboarding where you can see all the metrics of our cluster, our service, and our volumes. And I'm just giving you a cluster overview where we're running those 14 virtual machines on.
As a quick side note, wouldn't you say that traditionally, if you're doing any kind of performance work, you like to show your hero numbers with larger block sizes? You're using a pretty small block size here.
Oh, and this was also a requirement for the customer because no one has a larger block size, right? You have more throughput and therefore you got more data. That means that if you go for smaller block sizes, you gotta hammer the system, right? You want to push as many IOs as you can. When you also look at the hypervisors these days, right, they're blocking maximum 8 CPUs for performance, right? And with NVMe over TCP, what we're using, we want to use as much CPU so we can get our hands on. So it looks like we're a bit limited, but again, 14 virtual machines attached with direct access to the Lightbits cluster, right? Through VirtIO, I'm showing you 7030 read-write, 512 block size, and almost 1.2 million IOs.
What I'm hearing here is that you're actually using more real world scenario, real world numbers, and not just the hero numbers that you see on every other storage.
This is real world with an OpenShift environment. Yeah. And bear in mind, this is 3 nodes of Lightbits cluster, right? You see 3 servers, you see 6 nodes up here, right? Which means we're running dual instance to optimize performance. And what I'm going to do, right, we're picking up a separate virtual machine, but I'll talk you through that as we speak, right? But I just want to confirm to you that everything you're seeing in this demo, in this video, has this load. So I'm just showing you through. You can see the throughputs, 1.5 gig in total, and the read-write bandwidth. So now we're looking at the volume, right? So this is the individual volume, and we'll show you the latency, which is happening here, right? So it's pretty small latency, right? Read 200 microseconds roughly. And here are the virtual machines. So we just quickly moved from Grafana to OpenShift. And in OpenShift, we got 3 workers and they're all running virtual machines. So this is where our CSI driver comes into play, right? When you install the CSI driver through the OpenShift through the Red Hat Marketplace, you just install the CSI driver and you have the capabilities of running directly to Lightbits. Now, if you want to know how that works, that will be a different video. But now for the overview, I'm just showing you 14 of the virtual machines. We're scrolling down here, and we're going to pick one virtual machine to show you, okay, what is the things we're doing. Now, also what we've done, right, we're doing file testing, and with the file testing, you can see that we're using the 512 bytes, and we're pushing for multiple hours already, right? So it's not just we're running it now, we're pushing that in that load already for a couple of hours. Now we're going to create physical volume claims. Again, on the cluster, this is a Photon again. We're showing you 3 of the servers, what Lightbits is running on. We show you the drives on each server, all right? So this is 12 disks, a maximum 24. We're showing the volumes, and we're showing the different projects, right? So we see the default and Lightbits project, and I'm going to do multi-tenancy, and this is demo, right? So this is the project demo. We're still doing the performance, and now we're going to create as a multi-tenant inside OpenShift. We're going to create physical volume claims, right? So we have selected project demo in OpenShift, which we're selecting the Lightbits storage class for demo. We're creating a demo volume. We're doing 250 gigabytes of a block of storage, right, as a file server, and we created 250 gig. It will be there. It does, the refreshing takes more time than it actually does. So this is interesting why I'm not seeing anything here, right? But could be, there it is, right? So there's my volume, and here's my 250 terabytes. So this is not slowing on the Lightbits, but it's just the graphical UI. I've created a snapshot. So we have created a snapshot class in the backend. We use the snapshot class, and still we're doing 1.2 million IOs, and I just created a snapshot. Right? That's how quick it is. Looking here again in Lightbits, right? And you can see that we have here in demo our snapshot from the just created physical volume claim, right? And then 250 gigabytes of size, metadata only, right? So no blocks copied, just redirect on write and optimize your performance and your usable space.
So for snapshot management, I'm assuming we can, whether we're doing it from OpenShift or we are doing it native in Photon, we've got the ability to keep a snapshot, rename a snapshot, easily manage that, delete it, whatever. That's all functional right out of the UI.
Right off the UI, right? So we can do it through Photon indeed, or you do it through the UI from OpenShift, or you use the OC command lines or the CLI command lines from OpenShift, right? Because it's CSI driver, right? It's directly integrated with Lightbits. Or you can even use our CLI. So basically the 4 ways of doing this, and there's even a 5th way if you want to use REST APIs, right? So everything we're showing you here is doable through REST APIs and Lightbits. We do not hide any special commands. That means you can build your own environment if you want to. So if you have an operational UI yourself, it's very easy to adapt Lightbits into that with our own very wide API.
That sounds about as cloud native as you can get.
So indeed, the thing it is, right? We're truly cloud native for that perspective. All right, so we have our snapshot here, right? And when we click on the snapshot, or we going back, and we're still showing the 1.2 million IOs. Whilst we create the volume and the snapshot. Now, from the snapshot, right, we want to create a physical volume claim. So basically, we're cloning now the snapshot. It says restore, but basically what we've done effectively, we've created another physical volume. So when we go to volumes and we select now project demo, you will see that, hey, now I've got 2 times 250 gigabytes, right? And I stop it here, right? And with the 250 gigabytes, I just clone, right? Again, it's metadata. So we've used the snapshot the information to clone a new volume inside OpenShift, but we're not consuming any extra space, right?
So
and
it's
that's
thin
the cool
provision,
thing.
you're telling me.
Oh, well, the volume itself is already thin provisioned, but basically what we're doing is we manage our volumes through metadata. So basically we're copying our metadata. And that means that the blocks are not touched. Only when you update the blocks, right? That's when we start allocating a new page basically for the original volume, not for the snapshots, not for the clones. So if I even run 1,000 snapshots and around 1,000 snapshots and around 1,000 clones, just imagine that you will only update the original locator of the maintainer of the volume itself.
That's
right?
much
Nothing
more
in the middle.
efficient. A much
And
more
faster.
efficient. Yeah.
So it's efficiency, but also the speed, right? And that's basically, again, the 1.2 million we're doing, everything we just did, right? It's happening underneath that, right? So it's not copying data, unnecessary uses of your NVMe devices for what, right? And that's the question. It needs to make sense before we do stuff. And the primary goal is to give you that low latency and this high performance. There's also a way of cloning the PVC directly. There's the clone. 250 gig, right? It was not like that instant. When I go back to my snapshots, or you don't see any on snapshot, right? Here's the demo. There's the third volume, and we're going to check on the volume which one it is. Still the 1.2 million IOs, right? Just referring that we're still running that heavy load. And let's delete one. Delete the form snaps copy. Boom, done. We're doing 1.2 million, right? So and the demo snapshot is gone, right? It was that quick. I'll just stop it for a second. So that's the key elements we're doing here, right? We have got so many cool intelligent flash management capabilities that we can drive this on our own core for management tasks. It doesn't sit in the way of your IOs. So we split our management capabilities and our data path capabilities over two different network segments. So all the creation of the volumes and the clones and the deletions of the snapshots, right, is happening through the management path, the left side. And on the other side, we're doing our data path. So all the IOs we're pushing, the 1.2 million IOs we're pushing, right, with all the data in it, is not harmed by creating physical volume claims or snapshot. Or the deletion of snapshot doesn't have to wait until a queue releases the time to delete snapshot. And that's core. And we've seen, when we did POCs with our competition, is that fact that under this load, right, we deleted the snapshot. They had to wait 10 minutes before the snapshot was deleted. Can you imagine that one? 10 minutes?
So they're waiting for garbage collection and other processes to finish before those blocks free up, and we're immediately freeing up those blocks for Excel use or what have you.
Exactly. So basically what we do, right, we just delete the metadata. And our intelligent flash management knows exactly where the data is stored on the NVMEs. The core engine we do, right, our engineering team built the NVMe stack on the SSDs. Our engineering team built NVMe over TCP. Imagine what it does, right? It's just connects like that. So from the client or from the integrators we're doing here, right? It's a direct command, poof, taken care of. And no waits. That's a beautiful thing.
Watching you manage this through OpenShift, it looks like it's native to OpenShift, not just because of the CSI, but because of how robust it is. We're not sitting here waiting for, like you said, any kind of delay. That's pretty impressive.
Yeah, true. And that's the cool thing. So if you continue this, right, without deleting the physical volume claim, done. Another one, done. I just deleted all three of them, right? Poof. So effectively, it's a 750 gig of allocation. Let's check the volumes. Let's check my project. Is my data still there? Done, right? And by the way, we're still pushing 1.2 million IOs, right? And that is the sophisticated way within Lightbits, making sure that your data is never harmed on what kind of management activities you're doing.
And I'm seeing latency on this device is sub-millisecond at the moment.
The latency here, right, if you look at the read latency, it's just going through here, right? We're just going through the yellow line, but it is less than 300 microseconds. And the write is around 275 microseconds. It's this amount of throughput, IOPS, and providing the low latencies. Again, the 1.2 million IOs, right? Oh, bear in mind, 3 servers, right? 3 Lightbits servers running 12 disks. That's it.
So if somebody needs more performance or more space, they either scale up or scale out.
Yeah, so that's the interesting, right? So basically, we can run the dual instance or single instance, right? Or if you have a dual socket or one, we can grow it up to 24 disks inside the server and up to 16 servers in a cluster. It has the ability to scale to 8 petabytes. And the beautiful thing behind the scenes, Rob, is the fact that once you add a new server into the cluster, we start automatically to redistribute the volumes across the new member. And that member will then suddenly own the primary path of the volume. Now you just added network capacity, you've added CPU power, and you've added performance from your NVMe disks, right? And there's nothing you have to do.
Got it.
And your application servers don't even know. Because the beautiful thing with NVMe over TCP, right, it has asynchronous namespace access, which means I have one primary path and a couple of inactive paths. But what we do with Lightbits, part of our CSI is our discovery client. And our cluster runs the discovery manager. And that reconnects from the new primary back to the client. So it's not multipathing on top of the client, but we're always used to a FireWire channel or iSCSI having multipathing, active pathing. We are doing completely different. We are here for auto healing and auto management capabilities. So the cluster decides where the volume should be run from the best server at that point in time, giving you the most optimum performance and the lowest latency we can drive.
Is that native from the CSI or native from the protocol itself?
That's native from Lightbits. right? So the protocol itself allows you to do that, but we're the only ones currently who are doing it like this.
Fantastic. I love that as a differentiator.
Yeah. And it proves the point, right? So again, I've just deleted all my volume claims. Now what we can do, right? Let's do a virtual machine migration. So I'm running we're checking now on the YAML file. We're checking the persistent volume claim, right? So here's our persistent volume claim, which is called 83E8. Remember that one. And where does it run, right? So we're gonna search now in this is 83.8. So we're running that one here, which is good. Also, what we're going to show is that we're going to use migration. So we right click on it and migrate, and then we choose to which, and I just select the one with the most cores available, and I migrate the virtual machine. Now, the cool thing is, what we're going to show you, right, is that currently it's just one connector connected, right? So I'll wait for this to come back, and I'll pause it for the moment. You can see the ACL here, right, has one node. Part of being able to do a live migration of virtual machine with attached physical volume claims means that you must have a read-write many capability for your CSI driver, right? Because otherwise you can't connect twice because you'll have data corruption. So that's the key thing, because both pods, both virtual machines will look at the same disk, and if there's no capture in the middle, you'll just overwrite each other's data, right? Part of our solution is we have created something in the middle which allows you to have multiple read-write at the same time for that same physical volume. So whilst we are just doing some refreshing in Photon, that's what you're seeing here, right? Bang, there you go. Now I've got node 17, I've got node 18. Right? So two different nodes running the same VM, running right to the disk, because we haven't stopped the performance, and both have access. Right? And that's the killer application as well, and that we can move under load. Now, the other beautiful thing is, whilst we're doing this, right, and we're looking at Grafana, do you see any dips? Look and see. Where are my dips, right? There are no dips. Yeah, you would expect that, right? But that's a beautiful thing. And when we refresh, right, you'll see that that second node has dropped off in any second. But we're still doing this 1.2 million IOs. And we're still doing the migration. It's now running, so we've migrated from one to the other. No performance penalties on latency or on IOs. As you can see, right, when we refresh it here again, there's no spikes, no drops for your performance. So I want to show you that. There we go, right? So we had two, now it's just one. We started at 18, we moved to 17, have them both active, and now we're on 17. And performance is still running. And that was basically the end of the demo for the customer. And it took 6 minutes, 7 minutes. They really wanted to see, does it perform on the load? Now we're moving forward with the prospect, right?
You're showing me a minimum node cluster. You're showing me a load on that cluster with small IO. You're showing me snapshotting, cloning, management, and cleanup of those. And then while all of that was happening, you finished those processes and went right into a migration of a 250 gig volume from one node to another natively. Is this OpenShift V? Is this KubeVirt?
This is OpenShift V, and part of the OpenShift V is some little attachment of KubeVirt, right? So they're using technology of KubeVirt, but it's all managed by OpenShift V. Yeah.
Perfect. So again, natively running either pods or VMs in the environment.
Yeah, all controlled through CSI, all controlled through basically the driver we've put in, and of course the discovery client, which makes the transition from one node to another so smooth.
This is 100% Lightbits only, Lightbits CSI. And I bring that up because we've got another video where we're talking about what we do with our partner InfoScale.
True.
Using our operators, their operators under an OpenShift environment as well. So this is
absolutely
just us.
And Rob, we should do another video, right? And let's talk about backup integrations, because if you look at Veeam or Veeam Custom, for instance, or you look at Valero, what these guys do with CSI driver, there's nothing yet to do for Lightbits, and it just works. That's how cool our CSI driver is to handle snapshots, to handle clones, and to handle your backup requirements, and restore, of course.
I love that, and I'm going to stop you there because that's going to be another video.
Yes, it should.
All right, buddy. I appreciate your time. Thank you for going over this with me. Thank you for helping me create this for the global audience and anybody who wants to take a look at this.
You're more than welcome.
You are You are a fantastic resource for the company. At the end on the bumper, there will be a way to contact us and reach out. So please watch the end of the video, which is the next couple of seconds, and you'll be able to hit either our YouTube or directly to our website. Thanks for your time, man. Appreciate you.
You're welcome, man.
Take care.